In Microsoft Fabric platform, you can build a live machine learning powered Power BI report using nothing but Python, a free Microsoft Fabric trial, no paid license, no gateway, no local Python install. By the end of this video, you will have a real forecasting model running inside Power BI service, showing actual sales alongside a Python generated prediction, built entirely for free and entirely beginner friendly. If you have never touched Fabric before, that's fine. We are going to start from zero and learn a few concepts as well. So please stick around and watch this video till the end. Initially, we will try to look at a few concepts. So first one is Microsoft Fabric. And a quick primer before we touch anything. Microsoft Fabric is Microsoft's all-in-one data platform. It bundles together data engineering, data science, and Power BI reporting, all sharing one common storage layer called OneLake. Think of OneLake as a single shared lake of data that every Fabric tool, notebooks, pipelines, warehouses, Power BI, etc., they can read from and write to without you copying the data around between different tools. And next, we will try to understand what is a lakehouse and why use one. So the first thing we are going to create is a lakehouse. Once we sign up for the Fabric trial and create a workspace, in that workspace, we can create a lakehouse. And a lakehouse is simply a storage container inside Fabric that holds your data as tables, the same way a database. But the difference is it is built on top of open file formats in OneLake. So why do we need a Lakehouse? Because our Python notebook needs to read raw data from somewhere, and also it needs to write its output back to somewhere so that Power BI can pick it up afterwards. So we want to create a Power BI report after following all the above steps. So the Power BI needs to pick up that data from somewhere. So that's the reason why we have to follow all these steps. And the Lakehouse is that shared meeting point between our Python code and our Power BI report. And a couple of more concepts now. And we will try to understand what is a direct lake and why use it. And the second concept, like I said, this is a direct lake. Normally, when Power BI connects to data, it either imports a full copy of that data into its own memory, which can get slow and stale over the time, or it queries the source live every single time, which can be slow too. Of course, there are different ways the data can be brought into Power BI ecosystem, but this is the common way the Power BI brings in the data. It will connect to the data and bring in the data. So by using a direct lake, what happens is this is a third option. It's unique to Fabric. So this direct lake, it reads data straight out of OneLake's storage at near import speed without actually duplicating it. This means the moment our Python notebook updates a table in the Lakehouse, Power BI can reflect that change without a separate slow refresh step. So for a forecast report, what we are trying to build, that might update daily. That's exactly what we want. So that's the reason we have this direct lake and lakehouse, etc. Now, the next logical thinking is that why do we need Python? Now, why bring Python into this at all? Power BI's native visuals and DAX formulas are great for slicing, filtering, and summarizing data. You already have that, right? Those concepts. But they were never designed for statistical modeling or machine learning. So as of now, there is no built-in way to train a forecasting model using DAX. And Python fills that exact gap. Instead of forcing that Python code into a native Python visual, which comes with licensing restrictions, regional limits, and also gateway requirements, we are going to run the Python inside a Fabric notebook, completely separating it from Power BI, and simply hand Power BI the finished result to display so that Power BI can use the finished table, and we can create the report and create some visuals in that report. So this is a common production friendly pattern because Power BI never has to run, license, or render any Python code itself. That's an advantage. So that's the reason why we use Python in a notebook in Fabric environment. Now, next, briefly, we'll see what we are building. And here is a full picture before we start clicking and looking at the code. If you haven't signed up for a free Fabric trial, then please do so. After logging into the trial account, we can see how we can create a workspace. And inside the workspace, we'll create a lakehouse for storage and a notebook for our Python code. The notebook will generate some sample sales data, then train a simple forecasting model on it. And finally, once that is done, we will write everything into a one clean combined table back to the lakehouse. Historical sales and predictor sales side by side. So that's what we want to show in the report. Then we'll build a direct lake semantic model on top of that single table and a Power BI report on top of that, all inside the same workspace. Next, if you haven't done, please sign up for Fabric trial. And once you have that trial set up, and log into your Fabric account using your credentials. And usually in this trial version, you will get 64 capacity units of trial compute plus 1 terabyte of OneLake storage. For usually it's about 60 days or 30 days, depends on the region. And as of now, that's what it is in some of the regions. And that's more than enough for everything we are doing today. And next, we will try to create a workspace. This is the step 2. Inside Fabric, create a workspace. If you go look at the left side menu, you have workspaces and click a new workspace. And what is a workspace? Briefly, we can think of a workspace as a project folder that holds everything we build today. In the workspace settings, under license type, assign it to your Fabric trial capacity. This is what unlocks Lakehouse's notebooks and direct lake for this workspace. So you have to do that once while you're creating your workspace. Next, once you create your workspace, go to the workspace as shown on the screen. We can create the step 3. We wanted to create initially Lakehouse, remember? So inside the workspace, select new item. And in the new window, you can give a name to the lakehouse. So for example, I have called mine as Sales Lakehouse. And once you select and create, Fabric opens the Lakehouse Explorer, which right now is empty, obviously, right? So no files, no tables yet. That's expected because we haven't done anything. So we will fill it in the next step. And the next step is we have to create and connect a notebook. So we are back in the workspace, and if I click on new item, then notebook, and I can search for that in the search area. And once you have clicked on notebook, the notebook opens, and this is the default template. And in the notebook's left-hand side Explorer panel, you need to add data items. So we need to choose existing lakehouse that we have created in the previous step and connect it to the sales lakehouse. That is the name which I have given. In your case, it could be different, but this is an important step. So by doing that, you will see the new lakehouse tables and files listed directly inside the notebook. This is the link that lets our Python code read and write to it. So that's pretty important. Then next is usually you have some data. You can pull in the data in different ways. But in this case, I just wanted to keep it simple. So we will try to use Python code and create a sample data. So this is the first code cell. So create a first code cell. So I thought rather than downloading a file, we'll generate a full year of realistic synthetic data, sales data, and write inside the notebook. So this keeps things pretty simple and dependency free for anyone following along. So this is the own plan, right? Any beginner can understand this example pretty easily. So this is the Python code. As you can see, a few lines of code. And let me try to explain this code. This Python code uses pandas. As you can see, we have imported those 2 libraries. And we are trying to build 365 days of sales figures, and with a gentle upward trend and a repeated weekly pattern layered in. So it looks like a real seasonal sales data rather than a flat line. So we then convert it into a Spark data frame. As you can see in the final step, the first few lines we have created the sales and stored them in a pandas data frame. And the final step, we are converting everything into a Spark data frame as shown in the final step. And Spark is the engine Fabric notebooks uses under the hood. So, and we write it into a lakehouse as a delta table named raw sales. Delta is simply the table format OneLake uses. So you don't need to know more than that for today. So once we run this particular cell and refresh the Lakehouse Explorer as shown, you should see the new table raw sales that appears here. Once we have done that, next step is we wanted to create a forecasting step, right, using Python code. And this is the actual Python moment this whole video is about, right? So we can create a new code cell. And in that cell, I have this Python code that has a forecasting step. So initially, as you can see, we have imported certain libraries, and we will read the delta table back, convert to pandas for scikit-learn as shown here. We're using this Spark functions, Spark read table function. And it's a pretty simple code. I think you should be able to understand. And we are also using the Python's most common machine learning libraries. So the model learns the trend in our historical sales and then predicts the next 30 days. That is the code. As you can see, the next step, you have the forecast the next 30 days. And once we have done that, we have a few steps. So let me just kind of explain it further. So this is an important design decision, I thought, and we want to avoid any mistakes. So it might seem natural to write the forecast into its own separate table and later build a relationship to the historical sales table inside Power BI. We can join these two tables, right? We can create the relationship. So I just don't want to do that here. So historical dates and forecast dates don't overlap at all. So a relationship between them would connect nothing, and your chart would show two disconnected lines instead of one continuous story, right? We wanted to show the historical data alongside the predicted values, right? So instead, what I thought is we combine both into a single table right here in the notebook. One date column and actual sales column and a predicted column with blanks where a date does not apply. We write that combined table into the Lakehouse as sales timeline. One table, no relationship needed, right? So, and Power BI can plot both columns straight out of the box. As you can see in the final line, we have done that. So that's the sales timeline table is created within this Lakehouse itself. So once we have that, we can run this cell and refresh the Lakehouse. We can see the two tables there. The new table also, the sales timeline table appears alongside the raw sales table. That's perfect. So sometimes you need to schedule the notebook. So in case if needed, you can look for the schedule on the top menu bar. And this is an optional but powerful step. So from the notebook's top menu, you can select schedule and set it to rerun daily. Now your forecast updates itself automatically every day with zero manual work. And because everything runs inside Fabric, there is no on-premises gateway that is required, unlike a typical Python and Power Query refresh. Remember, when you try to use Python and Power Query refresh or in visuals, you need a personal data gateway so that Python will render those visuals in Fabric or Power BI service. And once we have done that, there are a couple of steps left for us. And the next step is we go back into the Lakehouse, switch to SQL Analytics endpoint view, and using the drop down near the top right. So as shown here, you can do that. Confirm, you can see the sales timeline table. Refresh if you don't see it, and select new semantic model from the ribbon. Then we can give it a name, confirm the workspace, and select the sales timeline table. So once we do all this step, and the one which is left out is to confirm it. Once we select confirm, we should be able to see the semantic model here. So that's it. I think we have avoided the relationship, creating relationships between tables in Power BI. So we have not done that. And no relationship step was required because we have used simple code in Python notebook itself, and we have merged everything into one table back in the notebook, right? So Fabric automatically creates this semantic model in direct lake storage mode, meaning it reads live from the data table in OneLake and with no import and no stale data. So sometimes you might see some common errors. So let me call out one. For example, if you see we couldn't add or remove tables, it's usually a temporary capacity limit. Wait a few minutes and retry. So you should be able to see all of them there, the final table. Next is the final step here in this case is we want to build a report, right? So from the semantic model, we can select new report on the top and add a line chart visual. So we can drag that and we can add the data. So what we could do is on the x-axis for this line chart, we can drag the date and drag both actual sales and predictor sales onto the y-axis. So as two separate lines, right? And this way, we can see those two differences side by side, the historical data and the predicted values. So if needed, you can go to the format pane and give the predicted sales line a dashed style or some other based on your requirement. And that way we have a contrasting color. In case if you want, you can change the color of this line. So it's visually obvious where real data ends and the Python forecast begins. That single chart is the entire story of this video. In one glance, historical data flowing seamlessly into a machine learning prediction, all inside a native Power BI visual. So that's cool, right? So if needed, you can publish this to service. And if you want to share this among your peers, so you can publish the report to the same workspace and open it in Power BI service in your browser or in different fashion on your mobile devices or something. Anyone with access to this workspace can now see a live self-updating machine learning powered forecast with no Python visual, no gateway, and no license restrictions standing in the way. So that's a cool thing which we have done. In a short time, we have created this. So let us try to quickly recap and see what we actually built. We have built a Lakehouse to store our data, a notebook to generate data, the sample data, and then we have used another Python code cell to train, and we have added some code and trained a Python forecasting model. And finally, we have created a clean merge table, avoiding a common relationship mistake, a direct lake semantic model reading that table live, and a native Power BI report visualizing it all. We have used the line chart in that. So we have actual sales and predictor sales side by side, updating automatically, all in a completely free Fabric trial. So that's the complete free beginner-friendly way to bring Python into Power BI service. So thanks for watching. See you in the next video.